Assistant Professor,
Pharmacy here.
here.
Welcome to
Double side echo will be at first, I think so. நீங்க மொபைல் பண்றீங்களா இதுவா மேடம் சிஸ்டமா?
system தான் சார்.
மொபைலும் ஆன் பண்ணி வச்சிருக்கீங்களா?
இல்ல சார்.
Okay, you continue ma'am.
ஓகேவா சார்?
Yes, now okay.
Okay, sir. Good morning, esteemed guests, eminent speakers, respected colleagues, and dear participants. This is Rajita, Assistant Professor, Faculty of Pharmacy, BHER. Welcome to the Faculty Development Program, meticulously crafted to elevate the knowledge and skills of educators in the nanoparticles as colloidal drug delivery system. This program is spearheaded by Sir Dr. Ramesh Babu Janga, a highly esteemed senior professor at Chebrolo Hanumaya Institute of Pharmaceutical Sciences, Guntur. Dr. Ramesh brings an illustrious 30-year career in teaching and research. He earned his PhD from Acharya Nagarjuna University, Guntur, an M.Pharm from Tamil Nadu Dr. MGR Medical University, Chennai, and a B.Pharm from Gulbarga University, Gulbarga. His professional journey has been his impart knowledge at prestigious institutions like Rural College of Pharmacy, M.S. Ramaya College of Pharmacy, Venkateswara College of Pharmacy, Hindu College of Pharmacy, and Siddhartha College of Pharmaceutical Sciences, with over 30 guest lecturers and participation in more than 39 conferences. Sir Dr. Ramesh is a recognized voice in his field. He has received the Best Research Paper Award in Pharmaceutical Technology and has played a pivotal role in organizing national seminars and conventions. His scholarly contributions include 4 textbooks in physical pharmaceutics. Sir Dr. Ramesh research predominantly focuses on the design of oral control release formulation with 79 research papers and review articles published in national and international journals. His membership has been instrumental in guiding numerous PhD, M.Pharm, and undergraduate students, fostering their academic and professional development. He holds executive roles in APTI, that is Association of Pharmaceutical Teachers of India, and ABAP, Association of Biotechnology and Pharmacy, and is a life member of both APTI and Indian Pharmaceutical Association. Sir Dr. Ramesh profound expertise and unwavering commitment to the pharmaceutical sciences make him a valuable leader for this FDP. Join us in this enriching program to gain unparalleled insight from Dr. Sir Ramesh, extensive experience and to advance your expertise in nanoparticles as colloidal drug delivery system.
So, and I am very much happy to invite Ramesh Garu for the session. Sir is a well-known colleague, friend, well-wisher, a family member for us. I am very much happy to invite him on behalf of our Faculty of Pharmacy, Bharat Institute of Higher Education and Research. And I am very happy, it's a proud moment for me to invite Sir as a speaker for our first international FDP program, EFDP program. Thank you very much, sir, for joining with us. And once again, we are honored, sir, to receive you today.
Thank you.
And sir can start the session, sir. You can start the session, sir.
Can we start?
Yes, sir.
Yes, sir.
Okay. For your narrating of my experience as a part of introduction and your words about me. We have got association for a long time when you worked in Andhra and all. So let us start our program. Welcome to all. Now I am going to tell you some sort of principles in advances in research and innovations in our pharmaceutical sciences. As a part of our FDP program, so I am here today to say a few things, known or unknown things, which are known very well about me in my experience. I am going to share today for about 1 hour. Let us see this. Our title is Nanoparticles as a colloidal drug delivery systems. As the title says, nano. Why we prefer to go for nowadays? Everyone is running behind this now. nano. Even nowadays, we are all engaging with the cell phones. Without cell phone, nobody nowadays. I think everybody is accepting this now. Without cell phone, no one. In doing that, in preparation of cell phones also, the best communicative device, the nanotechnology is involved. So when the nanotechnology is involved in that communicative devices, what do you use that nanotechnology in our life sciences, the life-saving drugs? That is the main thought why the nano term is comes into the picture of pharmaceuticals. Since long it is working, but nowadays the utilization of this nano term is increasing like anything, and we are running behind that. Even while teaching in a class for PG students and research scholars, so we are all prepared to go for this nanoparticles and their arrangements. In relation to this, we are trying to prepare. Do a lot of research and try to prepare a lot of developmental activities of the systems. Right? This is regarding the simple introduction of these nanoparticles, because one more fundamental difference I could emphasize here. So, just last 15 years back, we are not aware of these nanoparticles. So, whether it is a colloidal or another kind of a dosage form. Now, after 15 years, only we are looking in. Prior to that, there is a convention. So there are so many problems the patients are facing the conventional drug delivery. That's why, so we are nowadays we avoid the various complaints from the patient side, because the ultimate benefit to be given to be sent to the patient. That is the main motto of the every pharmacist, whether they work in different kinds of areas in industry or in the teaching somewhere. The main focus is on patients. Patient life is important. Saving of patient is important. That's why because the patient has to feel free to submit the system which is in front of them. So when you compare the conventional old method of drug delivery, the novel drug delivery as a part of novel nanoparticles as a colloid drug delivery is a part of the novel drug delivery is working like anything by giving a lot of favorable states or conditions to patients. That's why that is the major reason why once again I selected this topic to narrate here in this context of this particular program. Okay? So the total contents of this talk, including the various contents of this topic, nanoparticles as a colloid drug delivery. So introduction, to some extent I have narrated, and every process and every device, every material, every method has got their own merits and demerits points. Similarly, this particular topic, which is considered as right now, is also having merits and demerits. Then there are different types of nano materials can be prepared, which can be classified. That's what the second next content is. Then to prepare the nanoparticles, there are so many polymers nowadays comes into the picture. There is a polymeric science. By using that, we can select which one is going to give a better frame or shape to the nanoparticles as a part of our studies. So therefore, there is a big classification and knowledge that is required to have this utilization of the polymers in terms of nanoparticle preparations. And to prepare that, we have to follow the methods. There are lots of methods there. A few methods are going to be adopted because all methods can't be used. And a few methods are working excellently. That's why we are also following that. Let us see what the different methods are going to use to prepare the nanoparticles. Once you prepare nanoparticles, you have to avoid it. That's what, whatever the in old home remedies also, household activity, whenever you prepare your food, so we are testing it. Without testing that, we cannot serve our family members or neighbors or relatives and friends. But the nanoparticles will be prepared as a colloid by using the above methods. We have to evaluate them. Then, by keeping the motto or objective, we are going to apply. So there are a lot of applications of it that also we can see in coming slides. So as I narrated broadly, now let us see as a part of this discussions to the viewers and to those who participated in this FDP program. Nanoparticles may be defined as based on the microns and submicron range of the particles. So which are forming as a colloidal systems, which is made up of large number of polymers. The polymers may be degraded valensically or not. So if it is degraded valensically, it has got one kind of activity. If it is not, it has got different kind of treatment to take it out. And it is not degradable. So therefore, so whenever you are dealing this preparation of the colloid dispersions with as nanoparticles, so we have to select the particle size should be micron and less. So which are made up of polymers. The polymers may be biodegradable or sometimes may not be biodegradable. So whatever the process or according to the process used for the preparation of nanoparticles, nanospheres or nanocapsules are going to be obtained. So these are the two types of the materials we are going to cut out from the preparation of the nanoparticles as spheres or capsules. So when you call nanocapsules or when you call nanospheres, nanocapsules are vesicular systems in which the drug is confined to a cavity. So it is nothing but an engulfing technology. So when you think of the complexes and protein binding topics in our discussions, in our studies, in our law, maybe in PG and UG cases, those are aware about the complexation phenomena. So, the same type of appearance we can see. Nanocapsules are vesicular systems in which the drug is confined to a cavity surrounded by a unique polymeric membrane. So therefore, here selecting of a polymer is an important criteria. So which is forming a cavity like in which it is going to confine the drug, in which vesicle, the drug molecules are going to be fixed as a cavity. That is the same area wherein gradually and slowly the drug goes on dispersing or distributing throughout that. So therefore, vesicular system is one of the important criteria to select prepare as a nanocapsules. Whereas nanospheres are matrix type. Nanocapsules are the cavities surrounded by any polymeric membrane, but whereas nanospheres are matrix system in which the drug is dispersed throughout the particles. So there is a simple difference is there, but it looks like the same. So based on that arrangement, they are going to deliver. So therefore, the nanoparticles are being prepared as nanocapsules or nanospheres. Remember, all of you, this is a stressable point. The nanocapsules or nanospheres are going to be framed based on the polymer solution. It is mainly polymeric membrane, and also it is how it is framed. In case of nanocapsule, one type of arrangement. In case of spheres, different kind of arrangement. So accordingly, they frame as a capsule or as spheres. Both of them are components of nanoparticles. So this is quite possible in case of liquids only. Mainly the polymer site is important to prepare either of these cases. So let us see if you prepare like this and frame like this, what are the advantages it has. And our aim is at a low level also, though the drug has got a minimum dose, so the drug has got a surfacial problems, area problems and all, we can convert those into this. And at the same time, the lasting, deciding time or residence time of the drug should be extended. That is the main motto why. Once you administer a dose, it may be extended around 24 hours. So therefore, once in a day administration, usually the patient will come forward to have this and with that they get benefit. That is the main motto and object to how the nanoparticles are working nowadays for those systems. So let us see some of the advantages of these nanoparticles. Either it may be nanocapsule or nanospheres, like that. The particle size and surface characteristics of nanoparticles can be easily manipulated to achieve both passive and active drug targeting after parenteral administration. So this is one more point I would like to emphasize here. This can be prepared as a colloidal, not as a powder form, not in a solid formulations. So, but it looks like a fusion mass. It looks like unique structure it has got. You can't find that the particles are a capsule or a sphere substance. The microscopic technique only, you could able to see and differentiate what kind of a structure the drug molecules and arrangement are being taking place throughout its preparations. They control, they go for the control and sustained release of the drug during transportation and at the site of location. So we want to make them to reach to the site of action. It can be made as a control mode or can be made as a sustained mode. The release patterns are these, all colloidal delivery systems. Subsequent clearance of the drug so as to achieve increase in drug therapeutic efficacy and reduction in the side effects. So one more advantage is there is a subsequent clearance to increase the drug therapeutic efficacy and reduce the side effects. So therefore less side effects are got and increase the therapeutic response or efficacy. Drug loading is relatively high, so there is a whenever you are preparing such kind of a high dosage form, it increases. The loading capacity should be more and more. Then relatively it has got high. A drug can be incorporated into the system without any hindrances or problems or chemical reactions. Site-specific targeting, also called targeted form, can be achieved by attaching targeting ligands to the surface of the particles. There is a, those are familiar in a pharmacy subject, complex system protein, and here you can understand this point very well. So ligand and specific target materials are there. The system can be used for various routes of administration, including oral, nasal, parenteral, intraocular, and so on. It cannot be confined to only one particular. There are so many advantages by which also we can supply to the system to have a maintain a therapeutic response maximum in the individuals. The every system has got merits and demerits. So just now we narrated a lot of meritorious points. Now every system has got a few meritorious points. Similarly, our nanoparticles as a colloidal form also has got a limited demeritorious points or disadvantages. They are small in size, having a large surface area. Usually, there is a coverage of pharmaceuticals. As the particle size, the globule size goes on decreases to the minimum extent, that is 1 micro or less, called subcolloidal range. There is a problem, there is a threat. It leads to the particle aggregation. Why it leads to the particle aggregation is there is an attainment of surface charges of the particles. That is only the one of the best reasons why they lead to the aggregation formats are called aggregates. Physical handling of nanoparticles is difficult. That's what I said, whether you observed or not. It is very difficult to handling physically. So it requires a specialized device to understand what exactly it is framed and how exactly it is. So especially in liquid and dry forms. Limited drug loading. Sometimes we are intended to go for the maximum drug load and with the advantages it has described. Also sometimes there is a chance of not having a that much drug loading what we intended. Maybe it will extend it to the limited extent. Toxic metabolites may form sometimes. There is a more threat. These are the 2 or 3 deleterious points under this. So the nanoparticles for drug delivery. The following different types of nanoparticles based on regular systems are made, maybe based on the metals, called metal-based nanoparticles, like here examples are gold, cadmium, zinc, etc. Lipid-based nanoparticles are called delivered as liposomes, neosomes, and other based carrier systems. This is one of the important area wherein you can have a lot of chance to go for the research liposomes and neosomes. Polymer-based nanoparticles. Now is existing in the market in the industry. Our industry is following this. Polymer-based nanoparticles. Dendrimus, micellar, and so on. So micelle is also one more important point. We have to concentrate on that while preparing these nanoparticles. Micelles are very dangerous. Biological nanoparticles. There is a bovine albumin serum based. This is a rare occasion. But the middle two are very lipid based and polymer based. Then metal based biological particles are very important. Let us see the classification of nanoparticles. So you can see the list of nanoparticles class: solid lipid nanoparticles, SLNs, polymeric nanoparticles, ceramic nanoparticles, hydrogel nanoparticles, co-polymerized peptide nanoparticles, nanocrystals and nanosuspenders, nanotubes and nanowires, functionalized nanocarriers, nanospheres and capsules. So we can break as a class, but which is available to the market and which is flourishing in the market is a matter among these. So that's what we are going to highlight then next slide onwards. Though we have got around 11 or 12 types of the nanoparticles, but all are not yet flourished. As for their invention side, they got patent, they invented, they reviewed, they tried to print, and they named all these, but flourishing the market, moving in the market is a matter. Getting a benefit of invention is a matter. So let us see how the preparation of the nanoparticles are going to be done. So by using the proteins, polysaccharides, and the synthetic polymers, we are going to prepare the nanoparticles. So the selection of the materials depends on so many other factors. It includes the size of the nanoparticle required, whether you go for the limited extent of 1 micron to the 10 micron or less than 1 micron to the lesser size of that, and so on, based on the size in which you want to play the preparation of nano size particles. That's what the colloidal form and trying to prepare. You have to select the materials. The material selection is dependent on the size which you need to do your nanoparticles. And some other inherent properties of the drugs, like so how it gets solubilized. So is it getting equal solubility or stability? I got the better solubility, better stability, and all. The next character is next point to be considered. Based on that, we are going to select surface characteristics such as charge and permeability. As I just now I narrated 2 slides before, as in a thumb rule, where it goes on reducing the particle size, the threat is there is an increase in the surface area. At the same time, it attains the charges. Such charges can't keep fine because we are running it at the highest speed rate. We are conducting this. It's more than 5,000 RPMs. So during that, the generation of the heat and generation of the sometimes the product may lead to the shock. So that all leads because of these surfacial properties, maybe charge or permeability and all. And the degree of biodegradability, how extent it is going to be biodegradable, biocompatible, and toxicity. So whatever the material we are sending in to the biological system, it should be degraded, compatible, and how extent sometimes you don't know, it may lead to the toxic. So you should have less toxicity, should have a degradable, compatible, and all based on factors. How extent that there is a degree, based on this degree you are going to select. Then one more important point is drug release profile desired. How you are intended to make them to release in the biological system, biological. Whether you want to extend your delivery for 12 hours or 24 hours or a week, something like that. So anti-density, that's one more important point by which you are going to select various materials. By using them, you can prepare the nanoparticles. They can evolve. So these are the list of the various types of preparations are available. Polymerization, majorly we are going to use this and it is working mostly. Then perform polymers and supercritical fluid technology. Another polymerization technique, there is a dispersion polymerization and emulsion polymerization. So just by dispersion the polymeric phenomena, we can do that or by in the form of the emulsion polymerization technique. Under emulsion techniques, by using organic phase and chemical phase or a type of required by following by using the polymerization technique. Under the polymerization phenomenon, there is a solvent evaporation method, but I don't think we are going to receive this the solvent evaporation method. It is there, but it has got some derivative response. In solvent displacement method, it is quite possible to do that the displacement of solvent. Then salting out, I think as per my knowledge, salting out technique is a limited extent of preparation involved in the nanoparticles. Then the final one and rocket one is supercritical fluid technology. So theoretically, when you look into the Martin's reference, very good reference that is, I do like very much about that reference. Very referring, I used to enjoy the Martin's reference. I have to try to follow that. I do suggest all the times the physical concept is by Martin. The supercritical fluid technology nowadays is upcoming technology. Already it is being used and there are products, but it has to come to the limelight. But I believe that it is a very good all the polymers, all the materials, you can only use to frame as a nanospheres or nanocapsules. One of the polymers we are using for nanoparticles. Natural hydrophilic polymers. So I am running, personally, I believe natural materials are having so many meritorious points than demerits. Whereas the synthetic ones we can frame, we feel it looks like, but one of the other times, it is not of disadvantages. I believe in natural, first case. Natural hydrophilic polymers, there are proteins and polysaccharides and other proteins. We know a lot, we have mentioned a few, gelatin, albumin, lecithin, legumin. All these are known elements, known materials. Polysaccharides, alginates, histones, hydrogen, agarose. They are also known agents. So available in the market, natural, under function of the natural hydrophilic polymers. As a polymer, we have to select one among these, how you want to deal with the natural polymers. And the synthetic ones, so here they mentioned, but I'm not that much familiar with this because basically my mindset is you don't turn to the synthetic, but it is important. But personally, I don't turn to that. Those who wish to deal with the synthetic, they can pre-polymerized polymers and polymerized in process polymers. Examples are quoted here. Let us see how the preparations of the nanoparticles is by polymerization can be done. There are two approaches. One is dispersion polymerization already depicted in one particular slide. Its various methods and explained. So it is used for preparation of biodegradable acrylamides and polymethyl methacrylates. Polymethyl methacrylate is a very good agent here. By using that, we can make the dispersion. The acrylates and methyl methacrylates more than once dissolved in aqueous phase. Then the polymerization by gamma irradiation or chemical initiation combined with the heating to temperature above 60 degrees centigrade. Whatever you dissolve the polymer in aqueous medium, it has to be polymerized at this condition. The polymers formed subsequently as aggregates and above certain molecular weight precipitates in the form of nanoparticles. So don't feel that aggregates are not dangerous in all the times. While preparing they form aggregates and combinedly from a nanoparticle. This is what I would like to emphasize that term aggregates and leads to the nanoparticles by applying your standard conditions of the preparation. Nanocapsules formation and their particle size depends on the concentration of surfactants and stabilizers used. So this is a valid point. What type of surfactant or polymer are being used and what is the stabilizing agent we are using in the formulation. Based on that, we are going to frame the nanocapsules. Second method, as I put at emulsion polymerization, once the monomer is available, monomer is take and dissolved in aqueous phase, contains an initiator. It is a surfactant. So you do the subject for the vigorous agitation, then you see that there is a formation of emulsion. Either of the cases, it may be aqueous or a pilot phase. The particles, we can receive the particles that are smaller than 100 nanometers. See that it is very, very less extent of the size, very, very less than the micro size. Here, the initiator is playing a role, which is it generates either radicals or ions depending upon the type of initiator, and these radicals or ions nucleate the monomolecular groups and starts forming a polymerization in that particular process. Second type of preparation is emulsion polymerization in organic and continuous phase. Water soluble monomers are acting as a polymerized phenomena here. While alkyl cyanoacrylate nanoparticles prepared by emulsion polymerization in continuous organic phase. So, in which what they do is the drug is first dissolved in an aqueous phase, emulsified, and then organic solvents containing surfactant is being added to that. Then microemulsion and monomer diffused in a swollen micelles are going to be seen at its conditions. The condition is important. Okay, so that we can have a nanospheres. Second method is solvent evaporation method. This is also a valid method. The drug and polymer is dissolved in organic solvent, which is emulsified with aqueous phase containing surfactant to obtain in water emulsions. Then the organic phase is then evaporated, which is a very simple job to get it evaporate. Then we can see whatever the residing bodies are called nanoparticles. We can see once it is organic phase is evolved. The polylactic acid nanoparticles loaded with this testosterone using a Plaxamar 188 is a very good polymer as a stabilizer here by using homogenizer. So this is one area where we can use the device called homogenizer. Homogenization. Then solvent displacement nano participation. As previous case, it also looks like the drug dissolved in organic phase. You may consider any organic phase like the most important solvents emulsified to that aqueous phase is added. Then displacement of organic phase is being done. Then immediate polymer precipitation because of the increase of the emulsion polymerization precipitation. Because of complete miscibility of both the phases leads to this. This is a sequential way of transformation you can see. When you go on adding aqueous phase to the organic, then displacement of phase leads to the precipitation of the then we can see and we can form the nanoparticles. So how we are going to confirm the nanoparticles? Just take a sample and send for the analysis. Then only we can say nanoparticles are being used. It is mainly this method is useful for the water soluble drugs. Sorting out method. It is suitable for the drugs and polymers that are soluble in all other solvents such as stone and ethanol. What they do is, in this method, the organic phase and aqueous phase are going to be subjected for the emulsification. Organic solvent, whatever the example is given, plus drug is dissolved in that. Then issue water and some of the polymers is being dispersed in that, and both of them are subjected for the mechanical study. Then emulsion is going to form oil water type. Then it is distilled, water is added. Then we can have this particular nanoparticles. So, as I stressed, supercritical fluid technology, it is an upcoming technology. So, but sometimes it is unstable. I had a very little experience with that. I read about this and gone through the various journals. I came to know from the physical pharmacy antidepressants. It is a very good technology. Then I tried. And, I succeeded to some extent, but stability is a major concern here. Right? This supercritical fluid technology has been investigated as an alternative to the biodegradable prepared micro and nanoparticles because supercritical fluids are safe environmentally. Because it is being exposed to the environment should not be hazard or a serious to the public environment. It can be generally defined as a solvent, supercritical fluid, a solvent, and if a temperature above its critical temperature is going to exist, at which the fluid remain as a single phase. There is not any separation or segregation. It is going to attain as a single phase, regardless of pressure. It involves use of environment-friendly solvents like supercritical carbon dioxide or nitrogen. So this is one of the important conditions we need to remember when you are going to would like to prepare a colloidal dispersion as a nanoparticles. These are conditions you have to satisfy. Without that, you don't get the any type of nanoparticles. And well point and important to be considered by those involved in this technology to prepare nanoparticles. It can be divided into rapid expansion of supercritical solution and supercritical anti-solvent system. So for drugs which are soluble, the rapid RES can be used. For insoluble drugs, this supercritical anti-solvent system can be followed. That's why the limited information is available. Still, that's why I'm telling you, for this a lot of scope is available. I have to try to focus in future. You may get a lot of scope to work on it as a part of your investment.
Sir? ಇಲ್ಲ ಸರ್ ಅವ್ರಿಗೆ ಏನೋ ಪ್ರಾಬ್ಲಮ್ ಕೂಡ ಸರ್ ಇಲ್ಲ ಸರ್ ಅವ್ರಿಗೆ ಪ್ರಾಬ್ಲಮ್ ಆಯ್ತು ಸರ್ ಕರೆಂಟ್ போச்சு போல
Discord, I am. They are radical problem. Huh?
Just a current interruption is there. Sir is joining. The current has been restored. Few moments. Sir is joining once again. So I think everybody can hear me.
Hello, yes.
Sir, thank you. Thank you.
Can I continue?
Yes, sir. You can continue, sir. Please, sir.
Hello, shall I continue?
Please, sir. Please, sir.
Okay.
Sir, continue, sir. You can continue, sir. Yes, sir.
Okay. Sorry, there is a power gone.
Doesn't matter, sir. Doesn't matter, sir. Sir, I think one thing you have to upload your PPT, right? PPT has come out.
Okay.
PPT upload பண்ணிருக்கீங்க.
Yes, it is. Can you see the slide?
No, sir. No.
Is it audible? Jonathan, is it, can I continue? upload பண்ணியாச்சு. கொஞ்சம் பாருங்க நீங்க. Hello. Sorry.
मैडम சொல்லுங்க மேடம்
நான் வெப்சைட்ல போனதுக்கு நிறைய ரெஜிஸ்ட்ரேஷன் தான் இல்லை. அது வந்து அட்மிஷன் டீடைல்ஸ் அப்படின்ற மாதிரி தான் இருக்குது. இன்னொரு விஷயம் போட்டேன். ஆனால் கான்டாக்ட் இன்ஃபர்மேஷன் போகும்போது ரெஸ்யூம் வந்து மெயின்
பண்ணியாச்சு. Now is it displaying or not?
விஜுவல் இல்ல சார், அதான் சார் நான் சொன்னேன். இல்லனா நாங்க ஷேர் பண்ணிக்குவோம் சார் எங்க சைடுல இருந்து. சார் ஒரே ஒரு நிமிஷம், இல்ல ஆல்ரெடி அனுப்பிச்சிட்டாங்க, ஹெலன் மேடம் மட்டும் தான் இருக்கு.
வீடுங்கடா போன் பண்ண டக்குன்னு. போன் இருக்கா பாக்கெட்ல? எங்க இருக்கு போனு? எடுத்துட்டு வாடா, போடா பேக் எடுத்துட்டு வாடா.
அட்மிஷன் இன்ஃபர்மேஷன்
ಇದು ವರ್ಕ್ ಆಗಿದಾ?
ரமேஷ் சார், ஹலோ
join Saira registration
வந்துருச்சு சார் ஓகே சார் வந்துருச்சு
until அந்த
இல்ல
site
இப்போ வந்துச்சு உள்ள வந்துச்சு திரும்ப போயிடுச்சு சார் பிபிடி இஸ் கமிங் சார் ஒன்ஸ் அகைன் யா இப்போ வந்துச்சு திரும்ப போயிடுச்சு ஒன்ஸ் அகைன் ட்ரை சார் கேம் ஓகே சார் it has come sir great sir thank you sir
Okay, can I continue? Right.
Yes, you can continue, sir.
Yes, really, there is expansion of the power. So under this supercritical fluid technology, I am very much interested. I have see this RES and CA technologies. Rapid expansion of supercritical fluid solutions. The drugs in which the drug is dissolved in a supercritical, whatever you are consider as a fluid supercritical, dissolve this drug in that and apply its method of preparation of solutions into the region of the low pressure. So these are all conditions of applying a low pressure drug. And then solid power of the supercritical fluid is decreased. So then we can have a precipitation of the nanoparticles. But it is somewhat difficult. That is the way. I personally but I could not. Then equipments of use generally for nanoparticles. Even in your laboratory, the list of the equipments you can also try trials, homogenizer, ultrasonic various types of gels, spray, milling, supercritical fluid technology, and its solutions, ultrasonization, nanofiltration, everything. So this is industrial mode of operation is a multinational unit. Really, if you get at any point of time when you get an opportunity to visit any industry, this kind of preparation. Colloidal mill, in which by using this we are going to use the nanoparticles, the spheres or capsules. By working really live, and when you see when live is going on, here you can enjoy with this and you feel like to work over there. This is my experience when I visited industry. I could able to see that. I feel all the times. I used to motivate the students to go in industry, not other fields, other areas of the Then once you prepare by using above list of the methods, then we cannot send directly to the market for the patients or peoples. So we have to analyze them. How we are going to analyze them? Confirm that there are nanospheres and nanoparticles capsules. One is in terms of its particle size, density, molecular weight, structure and crystallinity. These are all we are more familiar with all in the different level itself, and even when we really work in complex aspects, really we can go through all this. Similarly, we have to take consideration once the nanoparticles are prepared by using the above mentioned methods. This surface area, surface charge, this is more important. That's what it is actually the exact key point that is only the creation of the disturbance. If it is there in a manageable area, definitely we can have a very stable nanoparticle. And surface hydrophobicity, nanoparticles, yield, drug absorption efficiency. These are all above in PG level, and research scholars will enable to do all this. Particle size, how we are going to measure is based on the photon correlations spectroscopy. Especially for a very small particle, they do go for this. Photon scopy, laser diffractometry, bigger size particles, because we cannot combine only uniform size of the particle. Try to get uniform size of the particles, but there is a range, right to the nearer to the nano. for very small particles, they can identify this proton correlation spectroscopy. But whereas for a large particles, we can use this laser diffractometry. Then electron microscope. It required coating of a conductive material such as gold and limited, very limited to the trace surface. But as far as my knowledge, this can't be. The basic point is, under the disadvantages, very rare occasion in case of metals. Then, but we have to try. As a part of that, we can do this evaluation also. Then transmission electron microscope is called TEM. Is a easier method and permits differentiating between particles and capsules. Then atomic force microscopy, laser force microscopy, scaling set for high resolution of this we can use to evaluate particle size. Then density of that, it is also one more important point. There is a problem if the particles are having higher denser among those given micro, there is a chance to get it separate. Then it is some sort of destabilization of the material. That's why we have to consider the density factor also. Helium densitometer, air using as a gas picnometer is used to determine the density. The density gradient centrifugation. Similarly, the molecular weight we have to calculate by using this gel permeation chromatography, refractive index detector is used over there. Structure and crystallinity is one more important factor we need to consider. X-ray diffraction is most preferred to act for the structural arrangements. Thermoanalytic methods. The following list of 3 DSC, DTA, and thermogrammetry techniques. All these are very, very important for maybe pre-formulation aspects or after formulation of a material to find out structural activities and crystallinity nature of the materials. Then specific surface area. This will be calculated by this sarcophometer, but I don't think even I did not know. I did not come across about this as a analysis we can do, but we did not operate and see even. Surface charges and electronic mobility. The surface charge of a particle can be determined by measuring the particle velocity in electrical and see that how far it is doing its momentum. It's called electrical charge. Then laser droplet anemometry technique for determination of the particle velocity. How the particles are moving and what velocity is moving can be used by using the device. As a part of that, we can surface charges will be determined. Surface charge is also measured as electrical mobility. These are all devices we can find out all the factors. Zeta potential is one more important concept by measuring the electrical mobility of the materials. Surface hydrophobicity. There is an important influence on interaction of nanoparticles with the biological environment. Because surface hydrophobicity is least to the biological environment. That's why we have to do this. We have to find out. For that, hydrophobic interaction chromatography, two-phase partition, contact angle measurements will be carried out to determine this factor. Emitter release by using diffusion cell. Since long back we are using this. One more is ultrafiltration techniques, modified one is also used. And nanoparticle yield usually quite common phenomena to determine the yield of the materials. And last part of this program and my discussion is applications where they are going to apply. What for they are doing all this? So is it for the acute problems or chronic problems or very chronic problems? See, I put it, mentioned in the slide a few applications of these nanoparticles in case of cancer therapy. So the purpose is to target, to reduce toxicity, enhance uptake of anti-tumor reagent. For that purpose, the materials used are polyalkyl cyanoacrylate with anti-cancer agent. Be used in case of intracellular targeting reticuloendothelial system for intracellular interaction infections. Polyalkyl cyanoacrylates are being used in the application area intracellular targeting. not intracellular targeting. So for a deeper level, we are preparing as a liquid or dispersion in terms of nanoparticles. Then vaccine adjuvant. Prolonged system effective at all we want to see, or enhanced immune response we want to see. That purpose we are using this, preparing this as a vaccine adjuvants. The better used to prepare these polymethyl methacrylates and nanoparticle vaccines. DNA delivery to have a enhanced or increased bioavailability and higher expression levels. So DNA gelatin nanoparticles, DNA cytosine nanoparticles are being used as a DNA delivery. Ocular delivery, that's one most important area. Sarvendriyam Nayanam Pradhanam. We do always follow, we believe it. That's why if any problems occurred in, so we have to administer the populations. So with that, what are the problems we do face when it can be rectified? As a part of that, ocular delivery is also available. So improve the retention of blood and reduce this risk, washout of the material. This can be used. It will be used to prepare disease, polymethyl nanoparticles, and agents are being used as ocular delivery. These are some of the applications. For that purpose, we are using the polyimidation nanoparticles or manufactured space. These are some of the marketed brands prepared by well-known multinational manufacturing units. There is a Event, the top one. It is prepared by manufacturing company. And some of the examples I have quoted, I'm showing, trying to show the slide. The Pioneer way once again more important multinational industry. Then American-based American biosciences. So see this injectables they prepare as all these are dispersion techniques they use. Then oily moisturizers, P&G, Procter & Gamble, they also prepared a product, a medicated product. The different manufacturers are, especially I quoted a few, there are still a lot of industry nowadays is following and running behind these nanoparticles as a polar direct delivery. That's what my highlight and title is given for me to narrate a few things about that. Whatever I know, I just narrated for you that I hope you are going to know something about nanoparticles and their applications, what are the different agents are being used to prepare. So then a key point as a polymer is going to be used, what type of method they are going to be used, and what type of product you are going to receive, and what are its evaluation once the product is available. And all just narrated this test of the product. And thanks for giving me the opportunity. With that, I'm going to finish my talk. Thank you very much. Thank you all for your patient listening for the last 1 hour. Thank you.
Thank you very much, sir, for your wonderful presentation regarding the nanoparticle and the various preparation procedure and evaluations. Really, it is very nice and interesting to learn about the nanoparticle-oriented persons. The nanoparticle-based foundation as well as the evaluation process. Any questions from the audience? You can raise your hands.
Some problem with this, that's why.
Yes. Any persons? Vignesh sir, any persons in the YouTube live, anybody in the chat? Can you speak in?
Yes, sir.
YouTube live, any question can you? Thank you, sir. This is the time for single session. I request our team to give the few speeches about this today's session.
So there is a problem audio. Just can Can you chat it?
Sir, this is the shooting department, sir. Arun, sir, you are the better person to speak about your department, sir. But we are giving to you. And one more thing I want to say. Vibration. And one more thing I want to say. So, and the people who were in the session, we have to thank them a lot, because so the current has been in the SAR end, it was gone. So they were patiently waiting for the session to once again restart. Thank you very much for everybody. And sir, I know about sir's speech, tremendous speech from our. So I am very much happy as today sir given his excellent speech, and already in Siddhartha yearly sir will be giving a session while I am working there, and now I invited in Bharat.
Thank you.
It's your turn.
Now, speech.
Good afternoon. By heartfelt thanks to our team, sir, Dr. R. Srinivasan and Dr. R. Saravanan sir, Ratan sir, Dr. Rajaganapati sir, Jaya ma'am, and to all other faculties. As we come to the close of this enriching faculty development program, it is my privilege to deliver the vote of thanks. This program has been as resounding success, and it is all thanks to the collective efforts and contributions of many individuals. First and foremost, I would like to express our heartfelt gratitude to our keynote speaker, Sir Dr. Ramesh. Your insights into nanoparticles as colloidal drug delivery system, coupled with your extensive experience and knowledge, have greatly enriched our understanding and inspired us to strive for excellence in our respective fields. Your dedication and passion for your work have been truly motivating, and we deeply grateful for the time and effort you have invested in sharing your expertise with us. Our gratitude also goes to the administrative and support staff who have worked tirelessly to ensure that all arrangements were in place. Your support in managing the various aspects of the program has been crucial in this smooth execution. Once again, thank you for your contribution and participation. We look forward to seeing you at future events and continuing this journey of learning and development together. Thank you.
Thank you.
Thank you, ma'am.
For the excellent speech.
Thank you, sir.
Thank you, sir.
I request one madam to share the feedback link to the session box.
Sir. Sir, we will talk by phone, sir. Ramesh, sir.
Yes, sir.
And we can end the session today, sir. We can end the session today, sir.
Yes, sir. Once again, I thank all those to in this program, our deans, organizing members, leaders and group.
Nancy, Kodisuri.
Sir? Sir, voice கேட்கல sir. Sir, your voice not audible.
Sir, is it over? Sarvana sir is telling something? Oh, okay, thank you. Okay. Thank you. Okay. Which book, sir?